Alright, kind of hopefully a shorter video, but we'll see. It's kind of a deep subject, but on gravitational lensing. And this is more about the images they get from space, indicating that galaxies are in the wrong place or something else. And there's really good reason to believe none of that's possible. Einstein pointed out some very good reasons, and one of the reasons is it's the wrong shaped lens. Alright, gravity lenses do not capture a whole bunch of energy and then reduce it into one tiny little spot. So you're not going to see things brighter with a gravity lens. It can't really make anything brighter. It's going to do exactly the opposite. So if there was any lensing, it would be minuscule numbers of photons and be completely invisible. The lens is the wrong shape. Okay, gravity gets stronger. You go towards the middle. That means it's bending more, and it bends less the further out you go. Exact opposite of a magnifying lens. So it really has to be understood that there's geometry involved here. Now, an argument I haven't heard from anybody, but it seems obvious that all of the Hubble images would be absolute garbage if lensing actually happened. Because you have to understand, objects look like they get smaller when they're further away. They look smaller. They didn't really get smaller, okay? They are actually the same size as they were, and all that's changed is what photons you're viewing. You're only viewing photons from this pen when it's this far away. You're only viewing photons that are moving in towards each other. You're not viewing photons coming out from the pen. So the difference, okay, is the photons you're going to receive from an object. So the sun is much bigger. It's huge, gigantic thing. We see this little ball in the sky. All the light we're seeing has taken, let's say it's 1,000,000 miles across. I don't know what it doesn't really matter. The point is that the only light we're seeing is the light that's converging. So it's not parallel rays. They often say, that if you want to get parallel light, you take sunlight because it's parallel. It's pretty far from parallel. It's obviously a gigantic thing that's coning light to us. We're coning it with our pupil. All right, we're forcing, the only photons that get here are photons converging, okay? And the same thing's happening to a galaxy that we're going to observe in space. So if we're going to watch it, we're going to look at a galaxy. It's 300 light years across, gigantic. All right, and that's a reality for the whole path to the Hubble telescope. And so you're going to view something in 1 meter that's 300,000 light years across, which means all of the photons have to be converging. And it means it's doing it across a distance that might be 8 billion light years. All right, so it's gigantic amount of distance it's traveling across. So it means for at least half that distance, it was more than 150,000 light years across. The photons that you're going to see, the one from the outside of the galaxy and the one from the other side of the galaxy, they are literally, as they're traveling through space, 150 light years apart. And your theory is that whole travel for that 8 billion light years, that somehow they experienced exactly the same gravitational potential. So as they flew by other galaxies and flew by all kinds of crab nebulas and all kinds of bullshit, as they flew by all of that stuff, somehow they were bent exactly the same amount. I'd say it's a ludicrous I don't think it can happen that way. Yes, there's a lot of empty space in space, but there's not enough empty space to travel that far and say that two objects that far apart will experience exactly the same gravitational potential. So the simple argument is, I think, defeating the idea that those images are legitimate, is any capacity for you to really believe they could travel 4 billion light years at 150 light years apart or more. That's what it has to do. The photons are that far apart. And they still have to travel, another 4 billion light years, still converging, where they're still pretty far apart. And they can go by all kinds of objects, and they get bent exactly the same amount. I'd say that's just totally unrealistic as a possibility. And so I think it does defeat those images as being what they claim them to be. So I think lots of arguments can be made that none of them make any mathematical sense. So Einstein pointed out that you can't see an Einstein ring. You can't see two galaxies or two anything behind an object, where the light comes up from both sides and comes to us through some gravity, because the gravity isn't consistent. The light you're going to convey has to be a big enough object for you to collect it, so it has to be over a lot of space. So you're seeing a big image of it at the lens, and that means the gravity is changing rapidly, and so there's no way you could get anything like a clear image because all of the light would be getting distorted. But again, Einstein's point was is clearly as you move, as the photons go this way, they bend more, which means you're not going to see them. They're going the wrong place. And as it goes out this way, they're bending too little, and so it goes this way. So you're only going to get a tiny shred of the image, and it'd be such a tiny shred that we could never see it from Earth. So they ignore Einstein's argument. They ignore the geometry and the physics. And what they're using now is they're using the dark matter excuse. So anytime they find two objects, they want to make it rational because the math isn't rational. It's not circular. It's not spherical. They just spread a bunch of fake dark matter. And again, the dark matter itself, can you realistically say you can spread dark matter? Like I could take all the atoms of the sun and I could spread them around and they somehow wouldn't have to be spherical anymore? It's very unlikely, okay, that it wouldn't become spherical very quickly. So anyway, I have to spread them over an awful large area. And the larger area I spread the dark matter over, the weaker it is, and so the less likely it could possibly lens anything. You always have to reduce all this stuff to the, the theory is it's just matters of what the total mass is. And if I make the area that I spread the mass over bigger, it's still the same gravitational potential. So I have to have an awful lot of mass to create an object with enough gravity to reach that distance. So just because you spread it out here and put little bits of it over here makes no difference. It just matters because now your distance is still an insane amount of distance away from what the object would be if it was a point particle. It wouldn't have enough gravity to get to you. It wouldn't have enough to influence you. All right, so good enough. Yeah, 7 minutes isn't terrible. All right, we'll live with that.